So I've decided all warm-ups are optional. We're talking compound interest today, which you've done before. So quick little reminder, basically just plug things in, but your time needs to be in years when you do so. Say you owe $3,000. That is your initial amount, P, in your formula. R is, in this situation, 9.8% or 0.098. M is the number of times it's compounded per year. So if this is monthly, that makes M 12 times per year. So M is going to equal 12. And then we're finding the amount that we owe on this credit card after 5 years. So T is going to be 5. If you plug everything in, here's what it's going to look like. So we got our 3,000 times 1 plus 0.098 over 12 raised to the power of 12 times 5. Make sure you either do 12 times 5 and make it 60, or you have to have those parentheses around your exponent. I'm just going to pop up my Desmos scientific calculator and plug it in here, but you can do it in a real calculator too if you have one handy. Again, being careful with those parentheses around your exponent. And you can't use the fraction bar, like the little ABC thing, if you're doing this on a calculator in your rate divided by 12. It won't work. It'll pop up an error. So heads up on those things. You get $4,887.21. So obviously, not paying off your credit card is not a good idea. In this 5-year time period, we owed $3,000 to start with, and now we owe almost $5,000. So if we want to know how much the interest amount was that we basically screwed ourselves over by, you could subtract $3,000 from your amount that you owe now to get that you have racked up about $1,887.21 worth of interest by not paying things off. All right, let's do another couple. This one is the you have money in an account and someone's paying you, so we like this interest better. If you set up your formula here and pick out your information, what we've got is we need to know the interest rate to get our amount of money to increase to an ending amount of $7,000 in this 5 years. So plug in what you know. We're solving for our interest rate. I would divide both sides by 6,500 to start with, and that just leave you 1 plus r to the 5th power. You're going to need to do the 5th root of both sides to solve for r here. I left my 5 off on the 5th root on the right side. Sorry about that. Use the exact value that you get out of your calculator. I'm only writing that amount of decimal places down, but keep it all in your calculator. Don't round anything off until the very end. So use your answer key. Take your result, and since that's 1 plus r, we're going to subtract 1 from it, which gives you 0.0149. And your interest rate then, we usually go to 2 percentage points on our interest rate, would be 1.49%. Here we're looking to figure out what amount we need to invest right now to get our money to end up at $9,000 after 20 quarters. So my ending amount's going to be $9,000. I'm trying to solve this for P, my present value that I need invested right now. My time is measured in quarters here, which means a quarter is 4 times per year when you're talking about a number of times that it gets compounded. And when you go to plug in T here, we're looking for it after 20 quarters. That time in our expression is supposed to be measured in years. So that 20 quarters, if you divide by 5, notifications, or divide by 4, is going to give you 5 years for the number of years. So plug all that in, and then if you just take what's inside there, I just did it in my calculator, and it turned it nicely into 807 over 800 to the 20th power. You could get it as a decimal, do it and get approximately 1.19 with more decimal places. Again, don't round it off. You need to divide 9,000 by that value, so use your answer button, not anything rounded off. And that'll give you your present value that you need to invest right now to end up with $9,000 in for 20 quarters. Instead of being compounded like once a month, once a week, once a year, you can have what's called continuously compounded interest, which means it's basically compounded over and over and over and over and over and over again. It uses E as its base, so you just use the E button on your calculator, and it actually is a little bit simpler to calculate than compound interest that's not continuously is. If you plug your values in and multiply some things together, again making sure you have parentheses on your exponent, you end up with $5,637.48 for that.